This is problem number 11 from the online homework, and this is similar to the application problems that were on the one worksheet that was called applications, and there's a video posted of the solutions to that worksheet online as well. And you'll find that the problems there are very similar to problems here. The key phrase here when you're looking at these problems is you see there's a question about rate is changing. Okay, so change of rate of change, that is code for the derivative. So this is asking us to take the derivative or find the derivative of some function at some point. And so it's the rate of change of what? And if you look at what rate of changing modifies its average cost. So this is not asking for the rate at which the cost is changing, it's asking for the rate at which the average cost is changing. So the first step is I have to make sure I have a function that represents the thing that I'm going to compute the derivative of. So in this case I need a function that represents average cost. So in the book they denote this A like sub C, they put like a subscript on here. So we remember that as cost, but it's really just a function of x, and the average cost is given by the total cost divided by the number of items. So if I knew that I was manufacturing, for example, if I know that it costs me $2,000 to manufacture 200 items, then the average cost, I'd say the average cost for producing 200 items is $10, and it's dollars per item. So the average cost is how much it costs us to produce each one. So what happens in most manufacturing practices is that there are fixed and variable costs involved, and so what you expect is that the cost is always going to go up. It costs more to produce 300 than it costs to produce 200, and it costs more to produce 400 than it costs to produce 300. But the per item, the average cost goes down the more items you produce. That's the efficiency of mass production. Anyway, so the point is to read the problem carefully. Rate of change is code for a derivative, and then ask yourself, what am I asking for the derivative of? And the answer here is average cost, which is this thing, and the average cost formula then is 921 for this particular problem, right? There's different versions. Plus 14 root x over x. And so once I have that, then I'm in good shape to first of all find the derivative formula and then plug 400 in for x. That's going to be the question. So I'll do it real quick in case you want to try this one. You can pause the video here and and try it and then check your answer. But here I could simplify this algebraically, but I'll just go ahead and use the quotient rule since it looks like a quotient rule problem. And so I have I'll have an expression involving numerator and denominator, and it'll be denominator times derivative of numerator minus the derivative of the numerator times the denominator. So it's very similar to the product rule, but in the quotient rule we do have to get the order right because subtraction is, it doesn't matter what order we're in, and the denominator here is x squared. So this can be finished by simply figuring out what these two derivatives are. So I need to know what this is, and I know what that, well, the derivative of x is just 1, so that's not hard. And I'll have to write this one in. So I'll just go ahead and do that. And again, hopefully you've paused this so you can check your work against mine. But what I'll end up with for the derivative of that first thing over there, and this is what I end up with after it's simplified. So if you don't see it, just do the work and then see if that's not what you got. So that is this function represents the rate of change of average cost at the production level of x. So the question is asking And I wouldn't simplify that because I'm going to just stick a number into it anyway. And when I do the arithmetic, it doesn't really matter that it's been simplified or not. And if you simplify, you just have more risk of screwing it up. But if you put 400 in for x, I'll pause this and I'll figure out what that is. Well, I think the answer asks for like 4 decimal places, so I'll just write down what I got. So I got negative 0.0066. So that's my answer rounded to 4 decimal places. This this is in dollars per item, so dollars per jacket. Again, the average cost. This numerator, well, the average cost is also in dollars per item. So basically, it's how the dollars per item are changing with each additional item sold. So it's a little bit of a complicated unit. But the idea is that the average cost is going down. Notice how this is negative. That's about 7 cents, right? So, no, I'm sorry, about 1 cent, 0.66 cents, so less than 1 cent. So it's saying that the average cost is falling when you're up to the 400 jacket production level. The average cost is falling by 0.66 cents for each additional jacket that you make. So you expect that if you made 401 jackets, your average would go down. Your average cost per jacket would go down by 0.66 cents. If you made a 402nd jacket, the average cost would again go down by 0.66 cents. So that's what that means. You're expecting that the average cost per jacket will fall by 0.66 cents for each additional jacket you produce.